online? Probably soon. Close enough. Okay, so today the thing to do is make a panel. So we're working on that MS-20 filter, and we got the circuit working. You can see that over here. Maybe working? There it is. So this guy's working. We know it'll do everything we need to do, but we had it hooked up with alligator clips last time. So today we're going to draw up a panel that we can drill out. Now I use real thin aluminum stock normally. I got some new stock I want to try. I got some, I think it's 6181 extruded aluminum. I got some of this stuff from the hardware store. So what is this? Yeah, 1/16 of an inch thick. And so this is sturdier than the stuff I usually use, and I just that I just cut with a utility knife. This is sturdier stuff, so it's an upgrade. I got two ways I'm going to try to cut it. Not today, but I've got a 7-inch circular saw with a whole bunch of teeth, and I've got a jigsaw with a whole bunch of teeth. And I mean, one of those has got to cut through it, right? Make a nice, neat cut. So these two pieces that I have here, one of those is 1.5 inches, and the other is just 1 inch. I'm going to use some of the 1.5 inch stuff today. Now, in Eurorack land, everything is... Your Eurorack case is going to come in with the screws preset in 2/10 of an inch width increments. Those are HP. So you'll want to work in standard widths. My 1.5 inch piece here, that's not real Eurorack. So that will not fit well into a real Eurorack case without some overlap. That's okay. This is great. As you can see in the slideshow above, I just have a wooden case. So I make the rules on how wide something can be. And in my world, 1.5 inches is just fine. Also, because this module is going to be a pair, that means the whole two of them together would be 3 inches, which is 15 HP. That's a nice round number. Nothing wrong with that. So, I've noticed in the Discord that a lot of folks kind of get intimidated about drawing panels and drawing drilling templates. Like, it's a little bit, intimidating to try to put numbers to a real world drawing. So I use Inkscape. Actually is really good at this, and it's you just can print something up at home. Let's go over to Inkscape. So right here above my head, here we go, I'm still getting the hang of this. That's one I drew up earlier, and that's using a 6 HP, 6 horizontal pitch template. That's fine. I mean, I could cut 6 HP, but like I said, I've got this new stuff that at 1.5 inches, that's not 6 HP. That's like 7 and change. So I'm gonna draw up a new template today, and I thought while I was at it, I would show y'all how to make the required, do this in a quick way, working against actual measurements. I've got the reference documents we can pull up. I'll show you how to quickly put together these little templates that you can use to make your own drilling templates. Alright, so first things first. This is what we're going to make. This is a 5-knob. Each one of these represents a potentiometer, with the red circle being the red circle is going to be room on the front where the knob takes up. The black outline is what is taken up on the back of the panel. So this is kind of like, a multi-layer blueprint that we're looking at. So these on the left, those are knobs and potentiometers. This is a stereo 3.5mm jack. This is a 3.5mm LED hole, etc. And so the little crosses are the exact center of where I would want to punch when I am marking my tool in the spot that I want to drill. And so to take some of the mystery out of how I've done all of this, let's start from first principles, right? How do we know how big to make the panel? So here's my first reference material, and this is from the IntelliGel website. This is they make cases, and they've also come up with the shtick of the 1U panel. Now that's cool. I like 1U. We can get down on that. I've got some 1U in my how do we do it? This upper case here, that has that's 4U, 3U on the top, 1U on the bottom. Great form factor, highly recommend it. But anyway, what we're here for is a 3U. We're going to do a regular 3U Eurorack panel. And so there's a couple of interesting things here. We need to know, first of all, that green block, that's the typical PCB. That's the maximum height we want to use on the inside where we place our components so that we can clear the rails on the top and the bottom. That's okay, so that's good, right? And then so there's the next marking there in the middle is 128.5 millimeters for the distance between the top and bottom rail. So that's great to me. That's as far as I ever want to get. I don't want to take up all 3U of it because I don't know what my case is like. There's margins of error, and I don't want to, bump my panels into anything above or below. So, the important measurements here are 110 millimeters is the maximum height of a PCB, and 128.5 millimeters is the maximum height of the panel itself. So the first thing we're going to do is make ourselves a couple of template guides. You would probably call this kind of like a jig in the shop. So let's go back to Inkscape. Let's make our first one. Okay, so I'm gonna over here on the left. I don't know how to make my cursor highlighted, but on the left here we've got the shape tool for creating rectangles and squares. And on my screen there's a tooltip right now that says create rectangles and squares when I highlight over this, and I'm looking at OBS Studio and you are not seeing that. But that's okay. So I've got the rectangle and square tool. I'm gonna just shit out a little, it doesn't even matter, right? You need to create an object. We're working with vectors, so this is not like you're placing pixels one at a time. We've created the computer idea of a rectangle. That's why we had to use the rectangle tool. Okay, so we've got this thing. Now up at the top, there are some numbers. That's what we came for today. We love numbers. So we've got the width and the height. Well, the height is the main one we care about. And we know that inner PCB can be a maximum of 110 millimeters tall. The width, that's just how much space it's going to take up on my page. This is a template. So let's only make it 10 millimeters. Well, we're going to put some text on there. We'll make it 20 millimeters. Okay, I'm going to click in this other text box to apply. It's not apparent. I guess maybe I can hit enter. Yeah, there we go. Okay, so 20 millimeters. That's maybe, I could probably get away with a little bit less. 15? Oh yeah, let's take it down to 10. I just need room to put a label on it so we all know what it is. Okay. On the right hand side of the screen, I'm going to go over here and make this a fun color. So I'm going to click the fill. And we're going to fill it with, it doesn't matter. This is just something that we can live with. I don't understand what I'm looking at. Intellectually, I'm just going to drag the red. I want green. How do I get, I just got to keep sliding until I get green, huh? Green! I like that. Okay. Let's put some text on it. Get out of there. Okay, here's the text tool. Let's start by actually creating our text. We'll create a little window here, and we'll call it max PCB height 110. I've exceeded my text boundaries, millimeter. If I expand this, you'll see it. Okay, great. Up at the top of the screen, I'm going to Control A to make sure I'm selecting all the text. And then at the top, we're going to change this font size down to something we can work with. 13, will 13 fit? Yeah, that's fine. Okay, stay inside there with the text tool, like that, and then click out. And we haven't done anything exciting yet, I know. Let's rotate this so that it'll fit. Up at the top, there's a rotate tool that's just ready to go. Rotate that. Put that on top of the green. Anywhere is good. Now, for the first trick for the OCD, and I know there are a lot of you out there. Let's align these. This is going to be bread and butter. After numbers, align and distribute panel. So numbers are great, and then like relative measurements are even better. Okay, so we're going to select the max PCB height text thing. I've also gone back to my pointer tool. I'm not using the text tool anymore. We're done with that. Oh, I've double clicked and it's wanting to know more. Get out of there. Okay, using this and not the text tool, I'm gonna shift click on the green box, and now I have both of these things selected. Over on the right hand side of the screen, I've added the align and distribute to my dock here. Let's say you didn't have that. Let's figure it out together. View, I need the align and distribute thing. Where do you hide that? Show and hide? No. This is so important, that's why I wanted to take a minute. Because you gotta have, it's gotta be under view, right? View, display, align, show hide dialogues, Rogers messages, show hide, command snap controls. Okay, I'm gonna Google it, like a true genius. Inkscape, show, align, and distribute. Control-Shift-A. Open the dot in the command bar to the right of the canvas. Okay, alright, I know what you're talking about. Alright, back to Inkscape. Let's see. They're telling us it's somewhere over here in this tray. Where's Dora? Can you find the align and distribute button? I'm about to hit the Control-Shift-A, fam. Did they give us an icon over in this? Help me out here. It's like a bunch of stacked bars. Where's the stacked bars? Nothing. Alright, here's the tip. If you don't have an align and distribute button, press Control-Shift-A to add it to your tray. Alright, we figured it out. Now, in my excitement, Pikachu hurt itself. Scroll back in. Get back in there. Okay, first select the text box. Secondly, shift-click to select the green thing. And then over in align, we're going to do relative to the last selected. That's why we selected the text box first and then the thing, the green box. Okay, now, there's all these are my favorite buttons right here. So like this one, center on the vertical axis. Oh yeah, I love it. Okay, now do it again, but make it to where it's in the middle the other way too. Yes, exactly. Now, we got these two things. They're looking good together. Let's group them. Control G. Now, we'll click away, and if we come back, we can just click anywhere that feels right, and we can move this around, and both of those things stay together. Those are two important concepts. Align and distribute, and grouping, right? So that's the first, this is the first thing. Now we've got our template. We've got the max PCB height template. Let's do one for max panel height. Even though it doesn't really matter because what we're gonna do, let's skip that. Let's create another rectangle and square. This one's like this. Now from now on, we're not gonna do much of a fill because we're eventually gonna print this and let's save the earth. Paper is bad and ink is more precious than snake anti-venom. It's just expensive. Alright, so no fill on that. That's kind of confusing. And then if you click, at this point, if you click inside there, since there's no fill, you're not gripping anything, and that feels wrong to me. So I like to go ahead and select that again, give it a fill, but in terms of the fill to give it, gray is great, right? Because then it's different than the background, but not too in your way. Now, if you decide that you want to change the way that this border is drawn, you can do that. I'm going to change it to 0.2 millimeter, excuse me. A mil is a different thing. 0.2, right? I don't know why it just became a gradient. I'm not going to worry about it. It doesn't matter. Okay, so I changed that to be thinner. Now, when I did that, the size of the box includes the border. So this has now become a different size than we started. Fortunately, we didn't really dial in the settings to begin with. So now we've got a nice color. The border's good. We're going to select that. Let's lock the height in. The height is going to be not specified in inches. Go back to millimeters. 128.5. And the width, well, okay, so we went ahead and applied the 128.5. Let's make the width and this is another thing I love about it, is that it's comfortable with freedom units. The width is going to be 1.5. And now we have the right size panel. Okay. Now, why did I create that green box off to the side? Align and distribute. Okay. Take this thing, and we're gonna our second click now is gonna be on the gray box that represents our panel. Let's make them centered. So now that we know where our rails would be, and then I'm gonna use this one that has the yellow in the corner to butt that up against there. Now, I can, as I place my knobs and jacks on the panel, I can align their top edges to the top edge of this green box and know that I'm within the span of my rails, or the bottom edge of the box to know that I'm inside the rails. We're doing good. And then likewise, you can align to the center of the panel or to the middle, representing the vertical center, or the middle, the horizontal center. Okay, so the next question is, how do you know how big to make these knobs and jacks and whatnot? So your electronics parts supplier is going to give you, a lot of times the data sheet is available directly on their website. Like you can just click to download right when you're buying your 100K linear potentiometers. You can get the data sheet right there. Now, for a potentiometer, you're only going to need it once, and so today I just pulled up basically a random one. There are some subtle differences to pots, but for the purposes of today, most potentiometers are basically the same. So references, go to this scene. Here we go. On the left is the far left. I should, you know what? I'll just put a gap in there now because you can't tell that those are two different things. All right. Oh, put me on top. I got top. All right. Cool. Yeah. Okay. So on the left is the technical drawing for the jacks that I want to use on this panel, and on the right is the technical drawing for a potentiometer. We can look at this and answer a lot of questions about it, but the main one are the physical dimensions right over here by my face. Oh man, come on, left is right and right is left. There, yeah, this drawing right here. That's the one that's the most interesting to me, because it shows how far from the center of the shaft to the solder lugs. So when I drill the template, I need to know how much space on the back side of the template to leave room for those lugs, and so that I can get in there with my hands and solder, and so that they don't brush up against other components on other modules. So I got to know. I think that's basically the bread and butter for me here. I don't need to know anything about the height or the depth because I'm only working in 2 dimensions with this panel, right? You just go along the surface. The nut is not of particular import because when I buy these potentiometers, they come with nuts. So, and same with the washer. All that's not relevant. So going back to Inkscape, the trick is to draw up some sort of little representation of that potentiometer using the numbers from the previous page. And it just takes a minute, and basically the same way that we created this green block that is the text with the green, right? We're going to create a bunch of little rectangles and circles that represent the potentiometer and copy and paste until we're done. Like, that's the game. So I'll show you this one, and we'll see if we got any questions in chat. I haven't really been keeping an eye on it. Okay, so let's start. The easiest thing is probably to do that first circle and the inner potentiometer stuff. Where does it go? There it is. When I drill these things, I guess I need to know. I'm really studying it. Let's get a drink. I see that it's 7.8 millimeters from the center of the shaft to that. Oh, I don't know. It's like a little tooth. I don't even know if you guys can tell what that is. If you're not familiar, there's a little tooth on the front of the potentiometer body that bites into the panel that pretends it's a counter rotation nub of some kind, or anti-rotation tooth. I don't know. Oh, I guess by implicitly, if it takes an M7 nut, I need to know the M7 drilling size. That's that. Okay, so that's how you answer that question. I'm Googling it. M7 screw drilling drill size. Yeah. M7. So your drill size would be 6.1 millimeter, and we're gonna need that in freedom units though, because you can't get drill bits in every. I mean, you kind of can, but like when I go to Lowe's around the corner, because I'm not gonna special order, right? Anyway, this is also not super important because I don't need to mark the size of the hole. I just need to know the center of it. So, all right. We'll note that the center of it is, for an M7, is 6.1 millimeter, and 6.1, well, you can just use that directly. Since that's not going to be transferred to the drawing. I'll use whatever drill bit I have that's close enough, honestly. Like, it's not, because we're going to put that washer and the nut on there and call it a day. So if you miss it by, a couple of drill bit sizes, it's fine. Alright, let's zoom in, and let's go off to the side. Start with a circle. Change the fill to 0 on this, because the way that we're gonna draw this, we'll be able to grab it by some other part anyway. And up at the top, we can change the diameter, or the radius. Now, unfortunately, you have to do this in square, so you got to change the height and the width. That's fine. Okay, so now we got a 6.1 millimeter circle. That's good. While we're down here at the very bottom, the most detailed level, let's put together our cross for the drilling template, where we're actually going to push our scratch all. Oops, I'm showing you guys the wrong thing. Go back to Inkscape. So I drew the circle, and then I came up here to the top. No undo? Alright, no big deal. So we've drawn the circle, and then with the circle tool, if you grab it, you can come up here and change the dimensions of it. We've changed it to 6.1 in both X and Y. That's good. Next thing we need to do is put a marker at the exact center of this circle so that when we print it out, we know where to tap our awl to start the drilling process. So I'm going to go back to the rectangle tool. I'm going to crap out a very rudimentary rectangle that's very skinny. Change the fill. Make it black. Let's size that down some. How big did I make this other one over here? Is that about right? Yeah, that'll work. Okay. So there's one piece. Control C, Control V, copy and paste. Two of our best friends in the world on the computer. Rotate that 90 degrees, right? So now it's this way. I'm gonna shift click on the lower. I've got both of those selected, right? Back to align and distribute. We're gonna center it on the vertical axis and then center it on the horizontal axis, and we just made a plus sign, right? So now if I would grab this, oh no, we broke it. No, Control Z to undo. I reject that. Select all, or select this. Control G to group it. Now that I've got that group selected, we're on the right track. Let's just shift click this circle and repeat the process. Center on the vertical axis, center on the horizontal axis. And now we have created our first drilling rudiment, right? Oh wait, did you group them? You didn't group them. Control G to group. Now you've created a rudiment. This, uh-oh, that's wrong, right? That feels wrong to me. That we're supposed to just have the shaft marked, and we've got a whole knob outline. Let's go back to the drawing board, fam. Zoom in on that. In fact, let's come over here by the other one so we can keep it as a reference. This whole shenanigan should look like that. So where did we go wrong? Ah, radius versus diameter. Half of, let's select this with the tool. Half of 6.1 is 3.05. Okay, that's probably better. Yes, now we're getting there. Okay, there's our first drilling rudiment. And I mean, it's turtles all the way down. So we just keep creating rudiments, aligning and distributing, grouping, and repeating. It's a fractal. So there's the first one. Let's outline the pot body. Let's go together to the references page. So up at the top, right where it says full counterclockwise position or full CCW, that's not concealed carry weapon position. It's counterclockwise. Is going to be 17 units, 17 millimeter. So we'll go ahead and just mark that out as a oh my gosh, 8.5 millimeter radius circle. So go back to Inkscape, 8.5 millimeter circle. Click up at the top. Done. So let's compare that with my old work. Should be close. Yes, we're good. This should have no fill. Grab this, bring it here. You can see where we're going, right? We're going to click on both of these things. Center, center, Control G to group. Object, is it over here? If you want to do it, yeah, here you go. If you're a menu person, it's under the object menu to group and ungroup. All right, so we've done the circular parts of the back part of the potentiometer. Now I remember when I made this other one, making that rectangle and getting it centered was kind of tricky. So let's figure that out together. Do they tell us how wide it? They don't really mention. They tell us that it's 13 millimeters from the middle of the shaft to the outside of the solder lugs. Well, I guess you could look at it as the whole mess is, because they're telling you that it's 5 millimeters either direction. At the very bottom there, it says 1, 2, 3, 5, 5 at the bottom of the potentiometer body, right? About like right there. The two fives are telling us that it's 5 millimeters from the center of the potentiometer body to the center of the outside pins. And looking at that counter anti-rotation tooth up there, they're telling us that that's 2.8 millimeters plus 0 or maybe a little bit less. Interesting tolerances. It'll never be more than 2.8 millimeters big though. So if that's 2.8, I'm guessing it's like 1.5. So it's probably 6.5 millimeters from the center of the shaft to the outside of the solder lug. So that means from one solder lug to the other would be 6.5 times 2. That's 13 millimeters wide. And coincidentally, it's 13 millimeters from the center of the shaft to the outside of those lugs. I wonder if you make it an even 14 because to just account for that little bit of PCB that they put on there. Yeah, let's call it 14. 13 by 14. So come back over to Inkscape. We need a rectangular. You know what? And this time, I want a different type of stroke. I want one of those sweet mitered corners. Oh wait. We're doing the wrong thing. Hold on. Get out of that. Now see, you've done wrong, Brian. You've changed the stroke width on all that other stuff. Okay. Control Z. Have you memorized Control Z? I hope everybody at this point knows Control Z. Alright, go back to the rectangle tool. We have nothing selected this time. I'm going to just drop this here. Change stroke to 0.2 millimeters. Nice. Let's change the dimensions of the rectangle there to our pre-discussed 13 by 14. Where did it go? Hold on a sec. Oh, I know what happened. We just yeeted it off the page. We can get it back. Come back to me. Scroll in. Now what had happened was your boy Warpeggio clicked on the absolute coordinates of the shape instead of the relative size, or the size of the shape. So 13 by... Now he doesn't have his units correct. 15 by 14. Done. Finally. It's because y'all were watching. So that's basically it, right? So that goes there. It looks different than my old one, but I'm okay with it. Now, I was saying I wanted a different stroke style. I want it to be the roundy kind. Yeah, but you don't... I'm losing interest in it being the round kind. Oh, you have to make a radius, I bet. Markers? No, no markers. Yep, I'm over it. So it's square. Okay, move this like this and align. Now, how's he gonna get it? How is he gonna make it to where it's in the right spot? Right? Because you can't, there's not a button for that, and we grouped those things. What I can do is deselect everything, grab this square, control click allows me to go inside of a group. Now I could ungroup these things. That's one way to go. But and if you need to do that, that's fine. But just watch what I'm gonna do. Leave everything in place, and you need to select this inner that thing, right? Oh, okay. The control click. All right, I'll show you guys the easy way. Ungroup with Control Shift G. Control Shift G. And now we're almost down to component parts. Now everything is back to being like all loosey-goosey, right? So don't move anything. But grab this and that horizontal bar, align, and then use the align top edge to bottom edge of anchor. And so now that's right up on the bottom of that cross. Is that perfect? No, it should be in the center, but it's so small, you will not notice the difference. We are creating, what is this? This is the idea for us to work with, and we're going to remember that our measurements are not perfect when we're placing these components on the panel. So the first thing to do is put all this stuff back together. We've got everything centered up and aligned. This is our new potentiometer. Oops, you have to select all of it. There you go. All right, and group. There's our new potentiometer body dummy placeholder. So now we can use this anytime we want to represent a potentiometer on the board. So as I was saying, I think we could probably wrap up pretty quick here. You can see how we used a technical drawing from the IntelliGel panel drawings and our manufacturer's drawings. We used the data that's there to draw our template here and start adding placeholder parts. So when I get all of these on here, let's see. I want this one here, and I want to make sure that it's inside the rails, right? So I'll click this one in the green blocks, and let's make, using the align top edge of object to bottom edge of anchor. Oh, that was the wrong button. That was way not the right thing. What I really needed to do was align the top edges. That's this one. There we go. So that's a great spot, right? And then if you were the kind of person that just wanted to go down the middle of this panel, you could select the potentiometer group and then the panel group and align them like that. And that's how I make drilling templates. We only have one viewer right now. Thanks for joining us. I hope this was enlightening. If you have any questions, I'll hang out for a second. I hope that was, you feel like you could make a synthesizer panel for your Eurorack synthesizer now, or at least maybe you wanted to drill your own panel for something else. A busy box for your kid. You like putting knobs and switches. This is that kind of work. Yeah. Today's tunes were brought to you by 80 Stallone and we was listening to something else just a minute ago. It wasn't 80 Stallone. Digital Analog Digital, D.A.D. And they're both on the Bandcamp. So let's go back to 80 Stallone. That was good stuff. I don't see any questions in chat. Like I said to the one viewer out there, I appreciate you. I hope you follow. Let me go back to my main view. We're building a synthesizer here. This is the MS-20 filter board that we're working on. So this will be the actual meat and potatoes that's behind the panel that we're working on right now. I can, if you give me 1 second. I can show you the synthesizer itself. I use the work cam to do that. There's a little bit of a delay when I use this. Oh, it's upside down. That'll never do. Yeah, I don't know. Just take it off then. Is that right? That's right. I'm putting the thing on the doodad in the what's it. Phones have so many buttons. Alright, so there's the synthesizer. We're building one of these from scratch, right? Like you can do it. You can do it. If you can read a schematic, if you can follow instructions, and if you can solder, you can build a synthesizer. So normally I'd like to wrap up with a jam, but I feel like we've been going for a minute here, and I think we've covered the topic that I prepared for. I don't have any more material to go over. If I could just reiterate the main thrust of Inkscape here is this align and distribute tab, right? Creating shapes with the shape primitives on the left, and then aligning them. We didn't do very much distribute, but if you, I guess I could show that. The distribute, I don't really even use the one that they've got there. The one that I like the most is remove overlaps. So let's say I have 4 of these guys. We'll bring the 5. It's the whole party. Oh, you know what I'm noticing that it just did? That was that's doing snapping to the bounding and snapping. I don't want snapping right now, so I'm going to turn it off. And there's a little... That's this guy over here. Turn that off. Okay. All of these things, they're all catawampus, right? Line them up. Okay, that's good. Now, but they're overlapping, so I would like them to not overlap. I'm going to use this button right here. And this moves objects as little as possible so that their bounding boxes do not overlap. You have to kind of give it a little bit of help if you want something in a horizontal line or a vertical line. If you put these all together like this and then hit the button, it's going to do horizontal, I think, every time. So if you need them to be vertical, you got to help it out. So, you know, just like get in there and move them around. So now remove overlaps. And then if you want it to space them out a little further, you can use this thing. And it's, I don't know, oh, it's in pixel units. That's nice. So you can just, now there's 5 pixel units between them. From this, when you're working in pixels, that's not a real life unit. That's 5 pixels at whatever zoom level. So that's, here we are zoomed way the heck out. it moved it that much. If you Control Z that, select all, zoom, 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 zoom. This is what's nice about raster, right? It's not an actual, you didn't place pixels to make a square or a circle. It's the computer idea. So now if I do that 5, oh wow, I guess I was wrong. Because it moved quite a bit. So we learned something together there. 5 pixels are some sort of real unit. Anyway, 5 is fine. And so you could, I don't, oh, that's because I didn't give him a fill. That's what I keep talking about. It doesn't have a fill. 5 doesn't really fit. Okay, here's a fun thing. So if I just click this, they'll all turn. What if you wanted them to stay? What if that's not how you wanted the world to work? Watch this. Put them back, group them, and then do it, and now they're like that. That's a thing. I really can't think of any other tricks to show you at this point. I mean, it's align and distribute all day long. Raw numbers, raw shapes. So I think I'm going to hit it while I'm ahead. Thanks for joining me, one viewer. We'll see you next time. Next time we're actually going to make the panel, right? So like cutting aluminum, drilling aluminum, mounting potentiometers to a panel. And if I have energy at that point, I don't know how I would resist actually finishing the module. So anyway, good night.